All right, folks, welcome back, and we again appreciate you joining us and sticking with us today. We've gone through 6 modules already. We have 2 remaining modules, so still some cool, exciting stuff left for us to discuss. So don't go away; you don't want to miss. The next piece here we're going to be introducing is programming with T-SQL. There is enough components or pieces to this where you can actually do some really decent coding with it. So we're going to introduce some of the programming elements within T-SQL. We're going to talk about the fact that you can provide some error handling. So if your script doesn't work correctly, there's a way to do some catching and management of the errors. And we'll talk about the use of transactions when you're scripting out content using T-SQL. So we're going to spend some time talking about that. Now that we're comfortable with retrieving content and updating content and the implementation of defaults, constraints, and triggers, let's take a look at how we can manage content and T-SQL programming elements that are available to us for doing so. We've been mentioning this a little bit all day about the batches, the fact we can create T-SQL batches, which is really just a collection of one or several T-SQL statements that are sent to SQL Server. Then they're parsed, make sure they all make sense and things are all in place. They're optimized, and then they're compiled, and then they're executed as according to what we're asking for that script to do. Some statements that you'll find in there that will include create function, create procedures, create view. These can't be combined with others. So there are some restrictions you have to be aware of when you're looking at creating batches and making sure you can combine those types of batches together. This here is an example of a create view statement. We're creating a view. We saw this earlier on, just creating a view using a select statement to find what columns we want in the view. We're deciding where we're going to pull the content from, and we have a go on the end of it. Remember, that's our batch terminator, and this will create this view for us within a batch environment. Remember, the beauty of a script or a batch is the ability to have multiple T-SQL statements, and more importantly, if we save that out, we can schedule that to run at a later time. Now, batches are important to understand because they're parsed for syntax as a whole or as a unit. Syntax errors can cause the entire batch to be rejected. Runtime errors may allow the batch to continue after the failure by default, but you won't, by default, you also won't know that, so you have to be aware of that. So the good news is batches can contain error handling, and you'll see a couple situations here where we've got an insert into batch, and it's got a couple values, a couple rows of values we're adding, and then underneath here we've got an invalid batch. We're doing insert into a table, and that table doesn't exist. The batch is not going to give you any type of error handling indicating that was an issue. So we have to build in our own error handling to make sure we cover everything that we want to cover. Now, most often, we're going to want to reuse a batch. So what we're going to want to do is include variables. And this here is an example of creating a batch or in a variable. So we're going to declare salesperson ID. That's an int5. We're going to select order year. We're going to do a count on the distinct customer IDs. Then from there, we're going to do a select statement. We're going to grab the year from order date, and we're going to specify that as order year. Grab the customer ID. We're going to grab both of these from the sales order header where there's a certain ID that equals the ID that we passed in. So the beauty of this is I can reuse this batch because what I'm going to do is every time I run it, I'm going to pass it in a salesperson ID. Then this job is going to run, or these statements are going to be run against that salesperson ID that I passed. And with that, we'll go in and we'll create this as derived year, and we'll group by order year. So this gives us information, and it's an example of using variables and the reuse of batches by supplying variables that I can include whenever I want to execute that batch. Some additional information on working with variables: you can declare a variable, declare and initialize at the same time. You can create multiple variables, and we can use these and pass these as parameters into procedure as they're shown here. They're executing a procedure called prods by category, at number of rows equal number of rows, at cat ID equal cat ID or category ID, and this allows us to execute this procedure using the variables that we're passing in here. The other thing we can do is if we get complex names or trying to simplify how we're working with some of the objects, we can create what's called a synonym. A synonym is an alias, or it's a link to an object. Now, that object could be a local object, or it could be an object on a linked server. They can be used for referencing these objects. And as you can see here, we're going to create a synonym on the My Product table. and I'm sorry, we're going to create a synonym called my product for AdventureWorks production.product, and then we're going to be able to query the product table using the synonym to shorten that name required for us to reference that object. So we're going to select product ID and name from the synonym called my product, where product ID is less than 5, and then we'll execute that. So if you have lengthy names like you would in maybe a link server, or even some of the product names or that your object names that you're using, if there are multiple part names that you're using, we can create a synonym for that, and we can use that for accessing that content. These are like any other object. We create them with the create statement, we modify them with the alter statement, and we toast them with the drop statement. All right, because the toast statement isn't there yet, and it doesn't sound like it's going to get there in the near future. Is that what I'm hearing?
Correct.
Okay, I just want to make sure you haven't changed your mind. It's been a few hours, so I thought maybe, you might give in just a little bit. It's not going to happen, so I've got to write my own. Okay, so so batches, variables, and synonyms. We've got these available to us here. Let's go ahead and take a look at a couple of these here that we've got some set up here. Let's see, where am I? I got to get into my image this way here. So here we've got the idea. This is the what we saw earlier. We've got declare salesperson ID int is 283. That's what we were looking for a salesperson. We'll see if that's even valid. But so we're just going to grab this, highlight it, and this is a statement that I walked you through, so you have at least a little bit of understanding of what it's doing for us here. We'll try to execute it, and it doesn't like sales order header. So let's see what I did wrong here. Sales order header. I probably need, problem is I'm at master database here. Should have grabbed my use statement. So let me go ahead and throw that back up there. There we go. Now we'll run this baby. And you'll see by order year, 2005, 6, 7, and 8, customer counts 13, 24, 25, and 22 for the salesperson, 283. So that's the number of customers they had in 2005. So 2006, they almost doubled. 2007, they increased only by 1. And then 2008, they decreased by a couple. So starting to slack off a little bit there. So that's the idea of how we can use variables within a procedure and then actually execute them within that procedure. I also want to take a look at the idea of, that's a little too early for that piece. So that's what we're going to look at, that piece. We'll come back to this piece a little bit. It's using an if-else statement, but we're going to come back to that in the next section here. So we'll just jump back into our windows here. Is there anything else I wanted to demo in here? We did the variables. No, that pretty much covers the variables. Okay. All right, so that's good for that one. Let's jump back to our slide deck here. And inside of here, I'll get you to full screen so you can see everything that's going on here. And we're going to look at control flow options now. How we can control what's going on in a batch and how we can control the route that it takes, if you will, to be able to execute that batch or the statements within that batch. So SQL provides additional elements that control that flow and the execution of statements within there. The default is for statements to execute sequentially. But we can throw things in there like an if-else, a begin and, a while, or a return. And that's going to control what happens. So instead of just going sequentially down through the batch file, it's actually going to control using some of these control flow language elements to be able to decide what rows or where we want to go within that batch. So for an example here, I've got if object ID is production product and it's the user product. If it's not null, then print I am here and contain data, so don't delete me. So that's just a basic statement, just a basic if statement. Now, if we take it to the next level, we can throw an else in there. If object ID is not null, then print I'm here and contain data, so don't delete me. Otherwise, which means it doesn't exist, we can say table not found, so feel free to create one. Okay, so we can specify this. Now we're controlling what's going to happen here. So now I can go out there and create a table based on this else statement, or I can just bail out of here and say I want to purge data, or I want to select, perform a select statement because I know there's data that resides in this table. So we can use this. It's very helpful when we use the exist operator as well. But it's another way. This if-else allows us to control the flow of our content. We can also introduce the use of a while. So what we have here is we're going to declare a variable called business ent ID as an integer, and we're also as a title as an nvar char 50. And while business ent ID is less than or equal to 10, so we're going to give it some parameters, we're going to do a select title and job title from the employee table, where business ID equal what we passed in as business ID. We began with 10 here. We're going to print the title, all right, or the nvarchar for that business ent ID. And then we're going to set the business ent ID to equal what it is now plus 1. Because eventually, in order for this while loop to end, we got to get it up to number 10. So the first time it runs through, it's at number 1. When I execute this 1, it's going to increment it to number 2. It's going to run through the while loop a second time, a third, all the way up until it's number 10. And at that point, it will end that while loop and end the idea of displaying content for the title and the business entity ID. Now, we can also, within here, use a break or continue option to break out of this loop if we want to. So those are ways for us. We don't have to wait for the while loop. We can set up conditions in there where if a certain condition is met, hey, don't go up to number 10. We have a way for you to bail out of here. So control flow options. Do you have any cool demos you want to show for control flow options? I've got some of the ones I've just shown. I can use those, which is fine.
Yeah, go ahead, show the demos. I have something in mind for error handling and transactions.
Okay, perfect. So let me jump over here then, and we're going to go back into this image here, and scroll this down a little bit here. So in here we've got the if-else statement that we saw a little bit earlier. All right, so over here, we've got if object ID is not null, then print I'm here. If it is, then print table not found, so feel free to create one. So this is using the if-else statement. So we'll execute out here. Oh yeah, I'm here and contain data, so don't delete me. It gets printed out for us. So it found this object from within this table called object ID. It found an object called production.product. It's of the type of user, so it's going to display that content for me. Now, with that said, that's more error handling over there. We can also, like I said, we can set up a while loop. I showed you an example of that. I didn't bring that back in. I should have brought that in for us. But we have a while loop. We saw how that would work. And so this is just an example of how that would work for us. And again, we'll make these available for you so you can take a peek at these babies at a later time. So that's the idea of using control flow options, using just one example of those. We also have, and what we're going to introduce next is error handling, structured exception handling. So what we can do is use the try to run a block of commands, and then we use the catch to catch any errors. So it's called the try catch, obviously. It won't work for everything. So syntax or compile errors won't be caught. Some name resolution errors won't be caught. But what this does, it executes. It moves to the catch block of commands when an error does occur. So we're using the try, we're going to the try. If there's an error, it jumps out and down to the catch environment, and it uses the syntax that's in the catch environment. This way you don't need to check every statement to see if an error will occur. If an error does occur, you have to decide when we introduce transactions, if an error does occur, do we want to roll back the transaction and how we want to respond to that transaction. And we'll introduce transactions here in just a little bit. But this does some of the error checking for me. Now we can also query the error object. So common error object properties that you'll find are error number, error message, error severity, error procedure, and error line. Those are functions that we can query. And the property associated with them are the left-hand side and the descriptions on the right-hand side. If you remember that raise error message you saw earlier, there was a couple numbers associated with it. There was a severity level number, and there was an error number. So a severity level and a state number that was associated with that. So these are parts of the error message that you can create to generate your own messages. Values respond or return correspond to that information that's in the sysmessages view that's available here as an object, as a table here available to us, a system table available to us. So this is an example of a try block. What we're doing, we're going to begin the try, and we're going to force an error. We're going to try to perform a division by 0, which we know will error out. So we're going to do a begin try and then select 1 divided by 0. If there's an error, we're going to jump down into this begin catch. And what this is going to do is going to report information. So the error number is, and so what we define is in the catch, we define what we want returned to us. Well, I want to know the error number. That's one of the items in that table I showed you previously. I want to know the severity of that error, right? That's right here. I want to know the error state. If there's a procedure, I want to know if there's an error procedure. I want to know what line number that error occurred on. And lastly, if there's an error message that's returned, I want to see what the error message is that's returned, so I have an idea as to what I need to try to troubleshoot. So it's a fairly straightforward. You know it's going to generate an error because we're trying to divide by 0, which for some reason it doesn't work, whether it's Celsius or Fahrenheit. So the try and catch blocks won't catch everything, just to let you know. So this is an example. We're going to begin try up here. Table does not exist. We're going to do a select asterisk from I don't exist table, and we're going to end try. The catch is going to be begin catch, select error number and error message. Bad news is we're not going to use this here. We're going to just jump out, and it's not going to pick this up because some name resolution, like it can't find this I don't exist, the try catch won't work for that. So not all errors can be caught by try catch. There's some syntax, some compilation errors, and some name resolution errors won't be picked up by the try catch. So what you need to do is make sure you test everything and not assume that's going to catch the fact that if there's an error. Cause an error on purpose that you would want to be thrown over into the catch area, so it would execute and display the message that's associated with that. Speaking of throw, here's using the throw statement. Tobias had talked about that earlier where he said, instead of using the arrays error, you might want to use the new SQL Server 2012 throw statement. It's kind of replacing, and I'll use replacing in quotes here. The throw allows choices when handling your errors. So we're going to perform that begin try on the select. We're going to divide by 100 divided by 0. And we're going to set that up as a problem. And at the end of the try, we're going to begin a catch, and the print code inside catch is beginning. The my error is going to cast an error number as varchar, and then we're going to throw that. So throw is going to be introduced, and it was introduced in 2012, and we're going to use that throw that's going to give me some choices for what happens and how I respond to an error that occurs, in this case here in that try section. So we can use the throw for passing parameters to a user-defined error, or without parameters to re-raise an original error, the error that was caused originally by that. Now you said, are you ready? You want to go and throw this cool demo at us on error handling?
I'm not so sure about the cool part, but we will.
I'm absolutely confident it's going to be cool.
We'll show something. Yeah, let's do that. So first of all, just mentioning a little bit more details around this whole what we catch and what we don't catch. There are the big thing here is really around what type of error it is. So just like Brian mentioned, if it's a syntax error, we won't be able to catch it, as well as if it's a name resolution error, and that's due to the fact that we haven't started executing yet. So when you send a batch to the server, what we start with is we get a bunch of text, right? So we look at the text and say, whoa, what's in this text? And if I can't figure out what's the text, I don't know that there is a try, catch, etc. hiding in there. So the error happens before the try block is actually started. Same goes for name resolution. If you're trying to reference a table, when I try to compile this statement, I don't know what it is. But you can get around these things if you're generating SQL statements automatically, or manually rather, then you can catch it. So I'll just show an example of that, and we'll show some other examples that are interesting, especially with regards to throw. So starting out, you'll just do begin try, just select 1 divided by 0 as Brian likes. That seems to be his favorite error. And catch. So let's just start with this. If I just execute this, clearly divide by 0. Now the point of the catch block is obviously if anything happens within the try block, provided I get to start executing, I'll move to the catch block. So if I just execute this, you can see I didn't get any result back. Now we can just put an empty throw in here just to see that with throw it just throws whatever we caught in the catch block, so you get the actual error message back. Now with regards to this syntax error, so let's say I do hey in between here. you can see it didn't catch it because we didn't manage to parse this. So this text that came to us didn't make sense. But what I could do is I could say, well, I want to execute. So this is, you can execute stored procedures as Brian already shown. You can also execute what's called dynamic SQL, which means I pass a string in, the server compiles it and tries to run it. Now that thing actually happens within the try block, right? So I'll say here, begin Scooby-Doo. There we go. And now you can say incorrect syntax near Scooby-Doo. Right. And let me just add a select one in front of this so we see that clearly the select one happens, right? Yeah. So you can see how in this case we catch name resolution error or for example in this case the syntax error. So that kind of makes sense. Now the other thing I wanted to mention, which is more somewhat less clear, is this raise roar. Okay, why you should look at using throw instead. And let's just try it quickly. So raise roar, and why I say raise roar and not raise error is there's a only one E in there.
Missing an E, definitely, yeah.
Yeah, and I look at this as the IntelliSense of the 80s, right? Okay. So it's a little bit shorter. And I say, okay, the error message will pass an error here, and 16,1. What are these things? So this is the message we're going to send to the client. This is the severity level. It can be 0 to 25. 16 means miscellaneous user error. The more important thing is, if it's below 11, the client, like .NET, ODBC, and whatever, won't raise an error on the client side, so it's considered an informational message. If it's above 10, it's an error message. If it's above 19, in SQL Server, so in 20 and up, it's considered a fatal error and will go and cut your connection when we see that. So that's, obviously you then can't go and handle those errors. So raise roar 16, and then after that, I'll just put a select one. And as you can see, both of these happen, right? So by default with raise roar, the only thing that we actually do is send the error message to the client, but we continue processing. Okay, so that's all fine. Let's now say, we create a procedure that's called SP1, and all it does is raise roar 16.1, and then we create a procedure SP2, which let's just have SP1. That's going to be enough probably. Okay, good. So someone has been using SP1 for a long time, right? So let's say that they do begin transaction. And we'll go into transactions a bit more later, right? But then they do a bunch of stuff here. So select one is super important. Yeah. And then they do commit commit transaction after. And this clearly works fine, right? So we sent their message to the client, and then you go continue to select one, and then you go continue to commit your transaction. Now, someone, and this procedure has been there since the beginning of the ages, which is very common with databases, right? So I'll go ahead now and say, well, I want to use this in a try block. And then I'll have begin catch, end catch, and let's just do a throw in here to rethrow the error. So the procedure is exactly the same as before. I didn't change this. I just changed where I'm calling it from. And now when I run this, you notice that select one doesn't happen, right? And commit didn't happen either, so the transaction is still open and I have to go and commit it after, right? So this is a pretty big problem, right? If this means that depending on how the procedure is dynamically executed, right? What's the word? Sorry. How it's called, how it's nested. So if it's nested inside a try block, it behaves differently than if it's nested not inside a try block. Right. Which means control flow now depends on how the caller calls the procedure, which is can be a huge cause of errors. So this means that raise roar can sometimes change your control flow and sometimes not. So that's a big reason why you would like to avoid using it. So throw, the difference is just that throw always breaks. It always aborts. So if I just try this exact same thing, I'll just copy this And instead of this, I'll say throw, and I have to say the error numbers. I'll just say 50,000, which is the lowest that you can throw yourself. The message severity level, severity level is always 16 with throw, and then select one. Now you can see we never got to select one because throw automatically aborted the batch. So now SP2 will just do the throw here, and we'll do exec SP2. And we can see that it never got to select one or commit. So we would find this bug immediately, right? So it always behaves the same, meaning that now when I run select this SP2 in the try block, it behaves just as if I ran SP2 outside the try block. So throw is just more consistent than raise roar. And that's why we recommend you using throw instead of raise roar.
Very nice. Okay, so speaking of transactions, great segue for transactions for us. We're going to talk about transactions in this next piece here. Got a little ahead of myself. Let's talk about, there we go, transactions. That baby right there. So we're going to talk about transactions because very important part of our, especially for programming, we want to make sure that certain transactions or statements are handled consistently. Or if you have multiple statements that you need to happen all at once, and if one doesn't work, then none of them should work. That's pretty much where you're going to want to use a transaction. So let's say you're in a banking industry and you want to move some money from your savings to checking account. Well, there's going to be an update statement, and the update statement is going to say, so we're going to move from savings to checking. We're going to update statement says deduct $500 from my savings account. I'm going to have another update statement that says add $500 to my checking account. Now, if I didn't put that inside a transaction, I could update $500, run the statement that goes against my savings that deducts the $500. But if the system happens to bail on me at that point, it never gets to that second statement that says, oh yeah, you're supposed to deduct $500 from savings, but oh, by the way, you're also supposed to add $500 to the checking. But if I don't have that in a transaction where it's handled as a single unit of work, I'm not going to have that $500. I'm going to lose $500. I'm pretty sure my bank doesn't use transactions. I'm losing money all the time. So it's got to be because they're not using transactions. I don't know. It seems like money just seems to disappear. But anyways, we'll look into that. So information like that, where it has to be handled as a unit of work. If one fails, then everything has to fail. We can surround that. We use, as Tobias just pointed out, we use a begin tran and a commit tran to say, hey, look, this is not just a single statement that needs to execute. This is a series of statements that need to execute. And if you can't get down to that bottom piece where it says end tran, then we don't want anything to occur in that transaction. We want to roll that back. So that's what we're looking at. That's what a transaction is all about here. So this is an example. It's a group of tasks defined as a unit of work. These two tasks make up a unit of work. Insert into sales order header. We have a new order that came in. Well, this is the general information about the order is in the order header table, but the details are in the order detail table. So we want to make sure if we're adding content in the sales order header table that the content or the details about that also get added into the details table. So we want to make sure we can do that. And if we can't do that, then we're going to have a problem. So we need to make sure that we have a way to resolve that problem or how we're going to manage that problem. So the need for transactions are issues with batches. So we have a batch with transaction management. We're going to do that insert into this one succeeds, this one fails. All right. We have the idea of catching the error, but the problem with this is simple error handling, but it's not going to repair the fact that this already got inserted. All right. The information in the sales order header was added, but this wasn't. Hey, by the way, we had a problem, but we still have inconsistency in our data because we have information in the header table, but we don't have information in the detail table. So what we're going to want to do is we're going to want to introduce, as we were just seeing just a little bit ago, the begin transaction. Hey, what I want to do as a whole entire unit of work is I want to include this in the begin and in the try catch, but what I want to do is begin a transaction, and I want to insert into the header table. I also want to /need to insert the details about that into the details table. And then if nothing happens, if both of these are successful, meaning there's no errors, then we're going to commit that transaction. But oh, by the way, if there's a problem, what we want to do is get into the begin catch, and what we're going to do is we want to clean that up. And what we're going to do is say, hey, if you threw me down in here from the try, there must have been a problem within that unit of work. Something or everything didn't execute. It could be 2 commands, it could be 200 commands, statements. If they all 200, I don't care if 199 executed, if all 200 of them didn't execute, then we want to, instead of committing the transaction, we want to roll back that transaction, which means it's going to go back up to the sales order header table, and it's going to roll back that and not apply or insert this record into that sales order header information. So we talked about briefly earlier today, we talked about the idea of items get written to the transaction log, and then eventually they're written to the MDF file or to the data file. This is what's going to happen is it's going to see that we will roll back that transaction. It'll never commit that or write that to that MDF file. Kind of say it in an easier term here. So we create a unit of work by indicating that we want to use the begin transaction statement. That marks that starting point of an explicit user-defined transaction. And then we wait until we apply all these in order, and we wait for that commit transaction. If we never see that commit transaction, then we know there's an error. If we have a begin, we need to have a commit transaction, or we need to have a rollback transaction in order for that. So a begin transaction, and then an end transaction, and we can have a commit or a rollback associated with those to make sure that we have that content associated with, or that information is updated, like I talked about with my checking and my savings accounts. So here's my begin tran. All right, we're going to insert in the sales order header table. Here's my sales order detail table. If we make it down to the commit tran, everything's beauteous. We don't need to worry about throwing it into the catch block, and we're going to be able to make sure our content is added in both tables. In my case here is added to my both my savings and my checking account were updated appropriately. As this is alluding to, this is updating, it's adding content into my header table and to my details table to make sure that content remains in sync with each other here. So in your T-SQL code, if a transaction is successful, we want to make sure that we commit that transaction. If we have any issues, we want to roll that transaction back. So this is where we begin the catch. Now this is the try failed. It's going to jump it down into push this down into the catch block. We're going to select the error number. We're going to roll back that transaction, which means anything that was supposed to be applied up top into the try block is supposed to be applied to that header table. Don't apply it to the header table because we never made it down to the details table. That content was never added. We got thrown down into this catch block, which means something happened up top, and we want to make sure that nothing gets applied to those tables, because otherwise we'll have a header out there, a header table, a row in the header table, and we won't have any details about that row that's in the header table. So if that error occurs, we're going to roll back that transaction, and we'll have to retry that transaction to see if we can get that transaction to be successful. So we'll just come back around and try that transaction again. Now, by default, SQL Server doesn't automatically roll back transaction when errors occur. To roll them back, you can use the rollback statements and error handling as we just talked about, or enable this I call it exact abort, but specifies whether SQL Server is going to automatically roll that back. When this is on, your entire transaction is terminated and the rollback on the error will occur unless it's occurring within a try block. If it's off, which is your default setting, you should turn that on, or you should decide how you're going to handle the error check or error handling for transactions. And it's easy enough to turn on using this statement here if you want to turn that on. So demo on this, do you have anything lined up for us?
Yes.
I thought you'd had something slick for this one.
I was thinking of that, yeah. No, this is one of these pretty important things, right? So we'll show the kind of the standard example and just what you need to think about, and then we'll show that sometimes rewriting what you're doing and rethinking it may get you a more efficient solution. So I just do this common example that Brian mentioned, which is, I want to take out money from one account and I want to add it to another account. Or rather, in this case, I'll just say you want to withdraw X amount of money from the account, and I want to double check that the money is actually there and then do the withdrawal. Okay, so let's take a look here.
You can put it in my account after you withdraw if you want to. I can give you that number. I mean, I'm okay with that, totally. Yeah.
Thank you, Brian. That's so kind of you.
Yeah, just trying to be a team player.
It's all good. So let's take a look here. So let's just start by creating the accounts table. And I'm pretty sure people that work at banks, I'm sure some of you are listening, that's what you guys do all day. I need a new accounts table, so I'll add it, and then you can start taking your money in and out. So just do this, account ID and balance. And this is a very simple bank, so there's all we do are integers.
Nice.
This decimal stuff we don't really care for.
It's rounded up.
Yeah, rounding. Okay, so that's our accounts table, and then I'll just insert a row into it. So insert accounts, values. This is my account number, and I have 500 pirate money in my account. Okay. So now, in order to be able to show this, I need to use two connections to the server to kind of show the problem, because it's a timing-related issue, obviously. So I'll say begin transaction, and what I want to do here is I want to check if there's enough money in the account, and if there isn't, I want to abort, right? So if, let's say, exists, select star from the accounts table, and by the way, there's no benefit in using select one or anything like that. So select star, we're just checking for the existence here. As soon as we find at least one, we'll abort the query. Where account ID is equal to Scooby-Doo, and balance is at least, let's say I want to take out 400, okay? So if this doesn't exist, then there's something wrong, right? You don't have enough money in the account, or the account doesn't exist. So in that case, what I want to do is I want to roll back the transaction. And you may argue, why do I start the transaction at all? We'll look at why we want to do this. And then I want to throw, which will abort the execution and exit, right? The error, and say, okay, Tobias is too poor. And then state one.
Guess I'm not getting any money from you.
Correct.
Okay.
And then I want to actually do the withdrawal. So if I get down here, that means throw didn't abort, right? So then we want to take out the amount, right? So update accounts, set balance. And now we'll do this kind of in stages. So now I'll do the calculation in the app. So what I pass in is I want to take out 400, and I did the calculation in the app tier and say, well, it's currently 500, the app happens to know, so I want to set the balance to 100, okay? Right. Which is obviously a problem. So just do this and commit transaction. So this is kind of V1 of our banking app, and presumably we'll be fired for this at some point if we were actually working at a bank, right? But now, because this is a timing issue, I will have to kind of manually execute this and pretend that I am the control flow statement. So we'll say this is basically connection 1, and this is, since you probably figured out that myself and Brian are underpaid young people that run around and trying to afford, what is it we're trying to afford? Going to Disneyland.
Disneyland.
We like Disneyland. Yeah. So we have this scheme now. We know this bank is new, which means they have new software. And new software, potentially there are bugs. Because it has been run for fewer amount of time, right? Fewer time than older software. Okay.
Hasn't been thoroughly tested or debugged yet.
Yes,
so
correct. So the plan is, Tobias is going to go into the bank and try to withdraw money from his account. Mm-hmm. Brian is going to exactly at the same time go to the ATM and withdraw money from Tobias' account with Tobias' card. So I'll use my ID and he'll use my debit card.
Right.
Then hopefully we get some extra cash for our Disneyland trip. And we have synchronized our watches. Are you ready?
Yeah.
Okay.
Ready.
Good. So there we go.
Okay. Done.
So now we're at exactly whatever time it is in your, where you are watching from, we'll see us doing this. So this is Tobias in the bank connection, and then we have the connection which is Brian at ATM. They tell me it's automated or automatic teller machine.
Automatic teller machine, I think. That's the way they said it was. Yeah.
So simple to understand.
Yeah.
Okay. So sync. I am standing at the cashier and trying to kind of hold who or his or her hand so that they press the withdraw button exactly when Brian is going to punch in start on the ATM. So, okay, what happens? Tobias' transaction starts, Brian's transaction starts. Bank checks, does Tobias have enough money in the account? Yes, we get the row back. Clearly there is enough in the account. The ATM checks, is there enough money in Tobias's account? Yeah, there is. Great. Now you start wondering what kind of locks are being held in the table right now. Well, by default in SQL Server we use read committed snapshot or read committed isolation, which means we take a lock on the row to make sure there's no write exclusive locks already being held on the row, and then we release the lock. So that guarantees we did a committed read, right? There is no uncommitted data there. So this means if I go to a third connection and just check what locks are being held, we can see there are currently no row locks or any locks of that kind. Just trust me on, there are no locks on this row, on this table right now. So the bank computer continues. Obviously this didn't happen, so it goes and withdraws the money from my account and sets the new balance. Done. We don't commit yet. So now if I go back and check the locks, now we have an exclusive lock on that row in that table. So the row is locked. Okay. At the same time, Brian's ATM also goes on because it found that there was enough money in the account. It tries to do the update. It has to wait because the row is locked, right? We go back and check, and now we have, yes, Tobias has a grant on the lock on the row, and Brian is waiting to get an update lock on the row. Okay, so what happens? Well, Brian is waiting, or rather the ATM is waiting. The bank machine commits. I get the money from the cashier. Thank you. 400 pirate money. At the same time, ATM works fine. ATM commits, and Brian gets the money. I say goodbye to the cashier and then exit the bank. And we meet outside, and now we have 800 pirate money versus having just 400. And the bank at the same time checks what is the balance on the accounts. Well, it's 100.
Right.
Okay, so this is an example of where we actually lost data, right? So this is great for me and Brian. We go, oh, okay, perfect. Disneyland trip is looking good. And hence, you know, a little bit later, maybe we'll do this again. And this is very hypothetical. Very hypothetical. Like, by the way, my name is not Tobias, and this is not Brian.
Yeah, my name is Frank.
Yeah. Okay, so next time, the bank doesn't do too well because me and Brian obviously tell our friends, ooh, there's this scheme you can do. You just have to have synchronized watches. So bank upgrades. Now the system is going to do balance minus equals to 400. So we're going to actually do the subtraction at the data layer rather than up in the app. So the upgrade obviously happens at the ATM and the teller thingy. So I just do a quick, let's say I got my salary again, my 500 pirate money. We come back, we want to do the same thing. So I begin the transaction inside with the teller, checks, it has money. At the same time, Brian starts, the ATM checks, there is money. The update happens. Brian's update happens, or rather queues now.
Queues, yeah.
Commits, I get the money from the cashier, or from the teller, and Brian gets the money from the ATM. So this is all good. We managed to get 800, but if we now check the balance on the account, wherever we did that, V2 of the bank software is way better because at least now they know we were over...
Two separate transactions of 400 each. Now we're minus 300.
Yes, so now they'll probably charge me some overdraft thing. Right. But then you could obviously, they don't have this limits on how much you can take out, so I take out a lot. Okay, so let's say that the bank doesn't really like giving away this money or giving me this loan without having approved my credit limit. So let's look at V3 of the banking app. So now instead what it's really about is I want, when the select happens, I want it to keep the lock on the row. That is the problem that we're seeing, right? Is because the check doesn't keep the lock on the row, the update can succeed. So I'll say, what I want is obviously Brian's, or whatever transaction comes in second, wants it to queue already up in the select. So I'll say with UPD lock. And this is, there was someone in the chat that asked about for update. This is basically the same thing. So there are 3 basic lock types in SQL Server. The shared locks, which means 2 shared you can have on the same resource, often called read locks. Exclusive lock, you kind of hear on the name, right? It's only one can have an exclusive lock on any resource. Update lock is basically compatible with shared, but not other update or other exclusive locks, obviously. And what this means is, while I have an update lock, no one else can take another update lock, but other people can read at the same time. So it improves concurrency. What it means is, it means I'm reading now, but I have an intent to update later. So as long as you're reading and not intending to update later, go ahead. If you're also intending to update later, then no, not good. So V3 of the software, let's look at what happens. I get my salary again, and had to wait a little bit extra since I was negative on the account.
Right.
Begins the transaction, it checks and there is enough money. And now when we check the logs, we can see, aha, the select made it so that I got an update lock on the row. And now when Brian's ATM goes and begins the transaction, you can see how it queues on the select.
Right.
So it waits here. And if we now check the logs, we can see that, yeah, I have my grant on the update lock on the row, and Brian is waiting. So now, obviously my transaction then continues, withdraws the money, and you can see Brian is still waiting, and then commits. I got the money from the cashier in the bank, and now Brian got no rows back, right? Because this wasn't true anymore. So what he gets is this: Tobias is too poor.
Yep.
So now in V3 of the app, we fix the issue.
Yep.
So you can see how it's not actually very complicated, but it's important to know exactly what goes on and not think of transaction as something magical or weird. It's just very logical. Now let's just look at how we could make this just more efficient. So V4 of the app, just for performance reasons now, what we could do is this. And we don't actually need the transaction commit transaction statements anymore, but I'll just leave them in there for, or I can remove them just to be clear that I don't need them. So what I do instead is I'll just take this where clause and put it here. So only update if I have enough money, right? Let's add let's give me the money again. I got another salary. And then I just check if row count you could also use the output clause, but row count is practical here. So if row count is basically not 1, right, then something is wrong. Or let's add begin transaction. We know it shouldn't update anything, but let's just to be extra clear. So do the update, take out the money if there is money, and then we say, well, if it didn't update one row, that means there wasn't enough money, so then we roll back and throw out the error. And now you can clearly see I don't have to think about this with UPD lock or anything. I'm getting better performance since I'm only executing one statement instead of select and update. So I'll try this, works fine, run again.
Nope, can't do it.
Can't do it.
Nice.
So that gives you kind of an intro into transactions and what you need to think about.
Yeah, and you don't need to use them all the time, but definitely when there are certain things that you need to use as a single unit of work, as we introduced earlier. You know, batches are just a series of SQL statements. Maybe they're fine running sequentially, but there may be situations where you need them to run as a unit of work. Then you're going to need to begin in a commit transaction with some error handling on that to do a rollback in the event you need to do a rollback. And you'll be using variables. Those are a way for us to pass parameters into procedures to allow us to reuse that procedure multiple times. Procedure as one example, to reuse that stored procedure multiple times just by passing a different value in with that parameter. Synonyms we looked at for making it kind of shorter names for us to be able to access content, whether it be local content or content on a linked server. These are some of the control flow options that we saw earlier on slides. We got the if, we got the if else, and we have seen a really good demo on the begin and the try and the catch, and how that can be very helpful with error handling. And we were kind of wrapped up with talking about transactions and the series of transactions, and how that block of code has to all be successful. All the statements have to be successful. Otherwise, we're going to roll that back so nothing is applied to the database. And we looked at using the begin, commit, rollback transactions, and we can also set something at the system level for the on aborting on a transaction if it's not if it shouldn't be committed. So that's what we did in this module. What we're going to do is we're going to take a 10-minute break, and when we go take the 10-minute break, we are going to come back. We're going to finally wrap up in our final chapter. We're going to wrap up by talking about querying information. What kind of information do I have readily available to me to see how my system is running? We're going to look at dynamic management views. We're going to look at some of the system tables available to us. We're going to look at ways to look at our queries to see if they're running as optimal as possible, and if not, some ways that we can try to optimize those queries. So we'll see you back here in 10 minutes. Enjoy your break.